Welcome back. Another day of stage streaming. Coming back from the weekend. Subscribe, comment, drop a like if you haven't. Today, we do the streak and then we do flutter. Simple as that. Let's go. We're gonna do one question. Sum of two numbers. Come on. Next question. I did this before. Unidirectional search. Given two-dimensional matrix of characters board. String target. Return where the target can be found in the matrix going left to right. Or up and down unidirectionally. Interesting. Okay, so you can't do reverse. Just have to try it left to right or up to down. Do up or down function, left to right function. Left to right check. I'll take the board, take the word. Let's get the length first. I'm just gonna do it once. Cos length of board dot 0. Take the rows, columns. So if it's left to right, it must be iterating through the rows. Columns minus and that's at the end too. How long does this? How do you make sure you found it? Triple loops. If well, it's a row first and then columns. The algo is not very efficient, it feels like. After you break it, and then you have to go through all this, you have to return false. Check down. Boom. Looks like it ain't working. Hey. Okay. It's a logic bit. Doesn't go here. Hold on. 930. 3 should be equal. Good catch. Good catch. Let's see. Okay, that's okay. Debug it a little bit. Interesting. It doesn't go in here. Wow. Wow, wow, wow. Cause Sure, you're such an OG. You have like so high, such a high rating at 150 streaks. So impressive. Let's see if it does this. Okay, 255. Is that what I expected? Yes, that's what I expected. Interesting, it never goes in there. It's not a mistake, you're correct. It's the bug is somewhere else. Just before K loop. Don't think I do actually. Because I initialize before every ing loop. And when it's equal, it will be true. When it's not equal, I can't write to false first. Before I break. So it won't be like get the true and then forget. And I get out of here and try. Let's just see. Well, the thing is that it doesn't even run the K loop, which is a bigger issue. And why does it not run the K loop? I think it's because of this line. N is 5, cos 5, so range is 0, so it's not running, huh? +1. Yep. It's kind of slow. I think I'll do if columns are left to right, if columns are greater than or smaller than n, let's return false. It's shorter than a word. this, then the length just return false. A little bit, not that much faster at all. Look at the optimal solution. This is the thing. Transpose to this. Yep. Yeah, I don't see another way to do it. I fucking hate this. Not a bit 100%. When ON. How's this end? How's that all end? Join all of them already. And then when you search the word in the string, that's another end. Oh, easy. Doesn't. Anyway. Do we have time for Flutter? Yeah, I think this code is ON. N square. This line, this is N, and then this is another N. Where in text is ON plus N because KMP for string matching. Interesting. Hey Julia, looks like you're super famous. Wish I can see why. So, who's the highest level that ever show up in the stream? So we got 87 here. I think I've seen a few level 70 approximately. Like you can change the title. It's N and M like the small string and M like the big string's length, I guess. I feel like unless he created the dictionary beforehand of all the possible words, the search would not be less than n squared. Research. With KPM, KMP. Okay, I fucking hate this website, it's not even funny. It's so useless. Oh, Newth Morris Pratt. Where have I seen this? A word within the main string by implying observation that when the mismatch occurs, the embolus is X-match could begin. So passing the examination of previously matched characters. So what does that mean? Like once you search through it, it's like we're not gonna do Flutter today. It's a little bit late, but it's okay. I like interesting stuff like this. Yeah, I don't like Wikipedia that much either. But hey, sometimes it's kind of correct. You send me a link. Really have to turn on my jazz for this. That's okay. Pussy chart. Nope.
Welcome to Logic First. In this video, let's learn the KMP algorithm.
Sounds like a South Asian lady. That one.
Matching algorithm. We are given with a text string and also a pattern. We have to find the occurrence of this pattern in the text. First, let's have a look at the brute force or the naive approach to solve the string matching problem. It will then be easier for us to understand the KMP algorithm. With brute force, starting from the beginning, we consider every possible fit. We start with the 0th index. We have two different pointers for keeping track of the text and the pattern. If there is a mismatch in the beginning of the pattern itself, then we immediately move on to the next character present in the text. If the characters match, we increment both the pointers to check the next characters, and we continue doing this as long as the characters match. And when we find a mismatch later in the pattern like this, see here, the index of the pattern is 3 and we find a mismatch here, we have actually started our comparison from the first index. Now since we have a mismatch, we move back I to the second index and start comparing from this position. We continue doing this until we reach the end of the text. Consider this worst case example of brute force. Whenever there is a mismatch, the text pointer is moved backwards and we are doing a lot of comparisons. Clearly, brute force is not doing well when we have more repeated characters like this in both the text and the pattern. Say the text is of length n and the pattern is of length m. In the worst case scenario, what we do is we first start with here and do m comparisons, and then we start here and do another m comparisons. So we keep doing this until this point because there is no point starting from this position, the pattern will anyways be truncated. So this is the final starting point, which is n minus m plus 1. So for each of these n minus m plus 1 characters, we are doing m comparisons. So the worst case complexity is this. Analysis of time complexity itself comes into picture only for very large inputs, right? So n is obviously going to be very large when compared to m, the length of the pattern. So this can be considered as O of n into m. We can ignore the m square and the m terms since they are going to be very small. Before directly jumping into the algorithm, let's first think how to improve the brute force technique. Consider this easy example. We find that the first 4 characters match and the last character is a mismatch. With brute force, we go backwards and start comparing from this position. This going back is what is making the brute force approach very slow, right? So how can we avoid going backwards? When we find a mismatch like this, we know that the previous characters match, right? In this example, the previous 4 characters of the pattern matches with the previous 4 characters of the text. We know that this and this match, this and this match. Then what's the point in going all the way back and trying to compare this with this? So instead of going backwards like this, once we find a mismatch, can we just start comparing the pattern from this position, from where the mismatch was found, ignoring altogether all the previous characters of the text? Let's see.
That's dangerous. That's kind of dangerous though. What if this match, the first match the first, second match the second, but then they still are the same character? Like if you jump straight through, it's kind of
Here is
bad.
a mismatch, so we move forward and we are able to match the entire string here, but this definitely is not the right approach. It is working in this example because all the characters in the pattern are distinct. Consider this example now. The first 5 characters match and there is a mismatch here in the last character. If we go by our previous technique, that is, if we just ignore all the previously matched characters and just start comparing from this mismatched position, just like this, we will not be able to find the required pattern which is actually present here. We will be missing it. By totally ignoring the previously matched characters, we will be missing the overlapping characters like O and N in this case. So how exactly do we find these overlapping characters? We know that the previous 5 characters of the text as well as the pattern match when there is a mismatch in the 6th character of the pattern, right? With this information, just consider this particular substring, the first 5 characters. We know that the exact same 5 characters are present previously in the text, right? So in this substring, we have to find a prefix that is also a suffix so that we can match this prefix of the pattern with the suffix of the text and we can skip all the previous comparisons and start comparing from this.
So you search for the things that is the same.
Third position or exactly the second index of the array. Moreover, it is not just some prefix that is also a suffix, it should be a longest prefix that is also a suffix. Only then we can correctly match them and skip maximum comparisons. Here we have the mismatch in the 5th index of the pattern, right? Which means the index 0 to 4 exactly matches with the previous characters of the text. So now consider only this substring. In this substring, the longest prefix that is also a suffix is of length 2. If we pre-calculate this information for each index of the pattern and store it in an array, that is, until that particular index, what is the length of the longest prefix that is also a suffix? If we have that information readily, we can easily look up this table and determine what is the next position that we have to compare whenever a mismatch occurs. In this example, the mismatch occurs in the 5th index, which means until the 4th index, all the characters.
Oh, so it does it once. So it does it once, and then the longest. Wait, but it's every time though.
Have matched. And if I go to the 4th index of the table and if it tells me what is the length of the longest prefix that is also a suffix until 4th index, that is in this case, if it says 2, if I have that information, I will understand that the characters in the 0th and the 1st index are already matching. So it's enough if I start comparing from the 2nd index. I can skip all these comparisons without moving this pointer for the text. We are able to now determine from which position in the pattern we should begin our comparison.
Okay, I think I got it. It's just like pre-processing the string you're trying to match by kind of finding the prefix that's the same as this. So like for example, if you stop in this end, like here stop matching, and then you can remember the prefix would match here. The N, O, and S can move the O and N here. So you kind of, I don't know, it's saving you a little bit, but it doesn't save you that much, right?
So this is what is the logic behind the KMP algorithm. You are just pre-calculating a table which tells you for each index what is the longest prefix that is also a suffix until that point. So when you are searching through the string, whenever a mismatch occurs, you just can look up that table and determine from where you should start comparing in the pattern without even moving the text pointer. This algorithm was developed by Newt, Morris and Pratt independently, and it is the first ever linear time algorithm for string matching.
Not
Unlike
really.
brute force, it totally avoids the re-examination of the previously matched characters. For this example, let's try to fill up the entire LPS array. LPS stands for
Kind
the
of
longest
silly
prefix that
idea,
is
to
also
be
a suffix. When
honest.
you're calculating for the 0th index, just forget about the remaining part of the array. The length of the longest prefix that is also a suffix for this particular character
How
will be 0,
useful
right?
is
By
it though?
calculating for the first
Like
index, we have to take the
realistically,
first two characters into consideration.
because it like this algorithm is completely useless if I have a string that's have all unique characters like A B C D E, right? GMP is not human friendly algorithm. Why is that? I'll show her some respect. I'll watch it slightly slower.
Here, again, the length of the longest prefix that's also a suffix is 0. O is a prefix and N is the suffix. They are not equal. So that's why we have a 0. If you take ONI, again it will be 0. If you have trouble in understanding this, just write down all possible prefixes and the suffixes for this substring. For ONI, O is a prefix. ON is also a prefix. Similarly, I is a suffix. NI is also a suffix. None of these match. There is no prefix that is also a suffix. So that is why we have a 0 here. Don't take ONI as a prefix and ONI also as a suffix. This cannot be done. Why I cannot consider ONI as a prefix as well as a suffix? See here, ONI, ON is a substring. I can very well consider that as a prefix as well as a suffix, but then I have to start comparing from this position. I already know that this position does not match. The logic of computing this LPS array itself will be meaningless if I take the entire substring as prefix, so that's why we are not doing that. We also commonly say the longest proper prefix that is also a suffix. By proper, we mean this only, that is, we cannot consider the entire substring as a prefix. Anything less than that is only a proper prefix. Now when we consider the first four characters, O is a prefix and it is also a suffix. That is the longest prefix that we can find. That is also a suffix. So here we compute 1. Taking the first 5 characters, ON is a prefix and it is also a suffix, the longest possible prefix and suffix. So we have 2 here. Now considering the entire pattern, again there is no prefix that is also a suffix. I have just written down all possible prefixes and the suffixes. Nothing matches. So here again we have 0. Let's see the implementation with Python. For the search function, we receive the pattern and the text as the parameters. First, we compute the length of the text and store it in n, and then the length of the pattern is stored in m. We need to compute this LPS array. It should be of same length as the pattern, so we are initializing it with m zeros. We make use of a separate function to calculate the LPS. Let's get to the implementation of this function later in the video. First, let's finish off this search part. So during search, we have to compare starting from the beginning index of both the text and the pattern, right? So we need to have two different pointers for the pattern and the text. So we have I and j, and we are initializing them as 0 since we have to start from the beginning. We need to scan through the entire text input to find the pattern. So the loop runs until n, the length of the text. First we compare these two characters, and if we find a match, what are we supposed to do? We just have to increment both the pointers, right? So let's have that in an if. If the character at the text and the pattern matches, then we just have to increment both the pointers. The next 4 characters also match, so we keep incrementing the pointers, and there is a mismatch in the 5th index. When there is a mismatch in the 5th index of the pattern, we know that the index from 0 until 4 is a perfect match. So if we go to the LPS table and check what is the value at the 4th index of the table, it will tell us the length of the longest prefix that is also a suffix until this point, until the 4th index. It says 2. 2 indicates the length of ON. ON is the prefix and it is also a suffix. So when we see a 2 here, we can understand that the characters at the 0th and the 1st index are already matching with the previous characters of the text. So we can directly start comparing from the 2nd index like this. See here the value of j is 5, and we now have to go to the 4th index and see what is the value in the LPS table. So that is why we are assigning LPS of j minus 1 as the new j, because this is where we have to start our next comparison. Notice that I is going to remain the same. Wherever the mismatch occurred, we are still in the same position, and we just have shifted j by looking up the LPS table. Since we are finding LPS of j minus 1, we cannot do that when j is equal to 0, right? If j is 0, that is, if the first character itself does not match, we cannot find LPS of minus 1. So we can do this only when j is not equal to 0. What are we supposed to do when the mismatch occurs when j equal to 0? Take this simple example. Here the mismatch occurs in the first character itself. J is 0. So we just have to go to the next character in the text, right? We just have to increment I and j remains the same. So that is what we are doing here. Again, coming back to this example, If all the characters have matched, j will be equal to m, the length of the pattern. We have progressed until the end of the pattern. So if that is the case, we now have to print what is the occurrence. 3 is the starting index, right? We only know I is 8 and j is 5. So we just have to print what is I minus j. If you want to continue searching for all the occurrences of the pattern in the text, we just have to reset j again to LPS of j minus 1, just like how we did here. We simply cannot search from this point. There might be some overlap here as well. That's why we reset j to LPS of j minus 1 and continue searching further till the end of the text input. Coming to the implementation of the LPS array, it is almost going to be same as what we did in the search function. In the search function, we had a text and a pattern. We used two different pointers to match the string. But for the LPS computation, we only have the pattern here. We are going to make use of two different pointers, but the string matching has to be done within the pattern itself. We are going to make use of this I to progress till the end of the pattern, and this length is going to actually tell us the length of the matching prefix, that is also a suffix. To begin with, we can initialize length as 0 and I as 1. LPS of 0 will always be 0 because if you consider only the first character O, there is no prefix or suffix there. Here the length of the pattern is 6. I is going to move till the end of the pattern. Finding a match we can, right? The length pointer is still at 0, but now the 0th index is a match. So we are adding 1 to that and then assigning to LPS of I.
Okay, it's okay. I think I got it. Yeah, you guys have a lot of passion to go to those contests. It's like 7:30 and like in the morning or at night. Okay. I want to see how famous Pizzeria is. Don't mind me because I'm too new to this community. This. It's okay. I don't really want to use the code when I'm streaming Binarysearch. Actually, cut the stream a little bit shorter. It's not short, it's the nominal time. I think that's all. Why should we do Flutter tomorrow instead? Because we spent a whole day on this. Oh, that's the recording for today. Thanks for watching.